of the polynomial. A real number a is a 0 of the polynomial p of x. If p of a is equal to 0, then only we can say a is a 0 of the polynomial. That means this a is making p of x, the polynomial p of x, totally equal to 0. So that is called the 0 of the polynomial. So example you can see, there is x plus 1, p of x is equal to x plus 1. For what value of x, this total x plus 1 will be 0. That means for x is equal to minus 1, this minus 1 plus 1 0. So that this p of x is equal to x plus 1 will become a 0 for the value of x is equal to minus 1. So that this minus 1 is called 0 of this polynomial. So some conditions for some important points of 0 of the polynomial. 0 of the polynomial may be a 0, sometimes may be other value. And a 0 of the polynomial need not to be a 0. And every linear polynomial, that means the linear polynomial means which is having degree as 1, that will have only one and only one 0 for that polynomial. And a polynomial can have more than one 0 also. According to the degree of the polynomial, the zeros will be 1 or 2 or more than that. So if the polynomial has degree 1, that will have only one 0. The polynomial has 2 as a degree, then that polynomial will have 2 zeros. Like that, the 0 of the polynomial will be found. And sometimes it is also called as a root of the equation p of x. This is about 0 of the polynomial. Now, exercise 2, based on 0 of the polynomial, value of the polynomial p of x. You can find by substituting all the values. Here first question is like this: find the value of 5x minus 4x square plus 3 at x is equal to 0, x is equal to minus 1, x is equal to 2. Just keep, instead of x in this polynomial, 0 for one time, minus 1 one time, 2 one time. You will get different values for that. Like here you can see, at x is equal to 0, the value of polynomial 5x minus 4x square plus 3 is 5 into 0 minus 4 into 0 square plus 3. 0 minus 0 plus 3, 3. At 0 I found, remaining you can find, and you can find easily by using this application. Next question in the exercise 2.1. Find the p of 0, p of 1 and p of 2 for the polynomial p of y is equal to y square minus y plus 1. Like this, some problems are there. So, you have to find p of 0. P of 0 means instead of y, you can take 0. So, where 0 you are taking, in this polynomial we have to apply 0 wherever the y is. And p of 1 means instead of y, you can take 1 in the polynomial. Wherever y is there you can apply 1. And as usual, 2 instead of y. You can have the values, different values for the different p of 0, 1, p of 2, p of 1. Verification. P of x is equal to 3x plus 1. It is a problem. At x is equal to 1 by 3. You have to apply x is equal to 1 by 3 wherever x is in the polynomial. Then is it 0 of the polynomial or not? We have to verify. That means you can find like this: p of 1 by 3 is equal to 3 into 1 by 3 plus 1. Then 3 cancel. This is minus 1 I think. Then minus 1 plus 1 0. So this is verified. X is equal to minus 1 by 3 is a 0 of p of x. is equal to 3x plus 1. The fourth one, find the zero of the polynomial. P of x is equal to x plus 5, P of x is equal to 3x minus 2. Like some equations will be given. We have to find like let P of x is equal to 0. That means x minus 5, x plus 5 is equal to 0, x is equal to minus 5. That means for the polynomial P of x is equal to x plus 5, x is equal to minus 5 is a zero of the polynomial. Like this you can find all the problems. Exercise 2.2. Now we discuss about remainder theorem. Before that, going to discuss about remainder theorem. Earlier in our third or fourth class we have learned that is a division of any two numbers. Let us consider two numbers 15 and 6. If 15 is divided by 6 will go 2 times, 2 6 are 12, the remainder is 3. That means 15 is a dividend, 6 is a divisor, 2 is a quotient, 3 is a remainder. We know already. So to verify whether it is wrong or right, we have done in our previous classes, dividend is equal to divisor into quotient plus remainder. So 15 is equal to 16 to 2 plus 3, 6 2 is 12 plus 3 15. Yes, it is verified. That means here remainder is 3, here quotient is 2, divisor is 6. In the same way, if you consider two other numbers, if we consider 2, 6 and 12 and 6, 12 in the 12 6 will go 2 times 6 2 is 12, remainder is 0. Then 12 is equal to divisor 6 into quotient 2 plus remainder 0. We can write like this by using dividend is equal to divisor into quotient plus remainder. In the same way, in the expressions or in the polynomials we can do like this. If we are dividing P of x polynomial by G of x polynomial, where P of x is equal to x plus 3x square minus 1, G of x is equal to 1 plus x. If you divide, here we have to write this in an order of degree, that means 3x square plus x minus 1. So 1 plus x also writing in the form of x plus 1. Then 3 into x, 3x times will go x, 3x into x, 3x square, 3x into 1, 3x. While subtracting, we got minus 2x, and again we have taken minus 1. So again, minus 2, 2 into minus 2 into x, minus 2x, minus 2 into minus plus 1, minus 2. Then the remainder is, we got 1. That means the dividend which is given, 3x square plus x minus 1, will be equal to the product of divisor into quotient plus remainder. So by using this formula I wrote like this. Here we have to be known that the remainder always equal to the degree of, equal or less than the degree of divisor must be. And this will not greater than value of degree must be not have, so that this is very important point we have to learn here. So by using that we can define the remainder theorem is, here dividend is equal to P of x, dividend is equal to P of x, divisor is G of x into quotient is Q of x plus R of x. This is nothing but the rule for the remainder theorem, right? So here we have to conclude that the degree of G of x must be greater than R of x. That we have to conclude here. Then only it is possible. So we'll define the remainder theorem now. Let P of x be any polynomial of degree greater than or equal to 1. Greater than or equal to 1. That means the degree of this greater than or equal to 1 means it may be 2 degree or 3rd degree or 4th degree or whatever it may be, right? And let a be any real number if p of x is divided by linear polynomial x minus a, then the remainder is p of a. Once again, let p of x is any polynomial which is having degree greater than or equal to 1, and a be any real number, then p of x is divided by any linear polynomial like x minus a, then the remainder is equal to p of a. That is called remainder theorem. There is a proof for this also, we can prove. That is already we have taken p of x is a polynomial, a is a real number, g of x here we have taken x minus a. Then we can conclude that p of x is equal to g of x into q of x plus r of x. Then that is equal to g of x. Instead of g of x we can write x minus a, q of x we can write same, plus r of x here, r of x only. Right? The degree of x minus a is 1. The degree of x minus a is 1 means the degree of r of x will become 0. Degree of r of x will become 0. That means r of x is equal to 0. That is x minus a into q of x plus 0 we can write. So r of x is if r of x is any constant, let it be r, then p of x will become g of x, that means x minus a into q of x plus r. That means you can apply p of p of x minus a means x is equal to 0 of the polynomial x minus a is a, so that p of a is equal to a minus a q of x plus r. This means 0 into q of x 0 plus r. The remainder is r. If we let it a constant, if r is. So this is nothing but remainder theorem. That means by using this, we will not divide like this to find the remainder. Just we will find the value of the 0 of the divisor, 0 of the polynomial divisor. Then we will apply in this p of x. Then definitely we will find that remainder of the given expression. That means here you can see. So 0 of the polynomial, 0 of g of x is x plus 1 is equal to 0, x is equal to minus 1. If you apply this value in the p of x, that means p of minus 1 is equal to minus 1 plus p of 3 into minus 1 square minus 1. That means minus 1 square plus 1 into 3 minus 1, 3 minus 2, 1. We got 1 as a remainder. Here also we got 1 as a remainder. That means to avoid this division, you can follow this remainder theorem to find the remainder by applying the 0 of the, which is the divisor polynomial, 0 value of the polynomial. So